Alright, so hi, my name's Leo, and I'm going to be a rising senior at Pembroke High School. So for my starter project, I chose to do the motion alarm, which basically had an ultrasonic sensor that detected motion, and then it would send a signal to my piezo buzzer to have it vibrate at a certain wavelength, and that wavelength would then emit a sound. So for my main project, I chose the auto-balancing Segway, and as the name suggests, it's able to balance itself even when I tap it slightly. The reason why I chose this was because I was scrolling through all the hardest projects that Bootstrap offered, and I thought wow, Segway looks pretty cool, right? And then later on, Robin had emailed me. He told me that no one had actually successfully completed the project before. So I was like, oh, I'm gonna be the first one. Yeah. So let me show you a quick demo. So as you can see, if I tap it a little bit, it'll stay slightly upright. The gyroscope is a little tilted this way, so it kind of wants to go that way, but as you can see, it can kind of stay upright. So to build a Segway, I needed to use an Arduino Mini microcontroller, 2 DC motors, a motor driver, a gyroscope, and an accelerometer. So my Arduino will get values based on information gathered from the gyroscope and accelerometer. It will then transmit these values into my motor driver, and the motor driver will then turn on these 2 motors and have them spin at a certain magnitude, in a certain direction to compensate for any overcorrection that the robot has made. So how I get those values is through something called a PID controller, which stands for the proportional integral derivative. And this is like a dynamic closed loop system, which will take the values that I've gained from the previous instance and try to apply to the next instance to correct the robot and have it be upright. And then the reason why I'm using this motor driver is because the Arduino itself cannot actually power these 2 DC motors at the same time, nor can I actually change the direction. So I need to use that motor driver so I can accomplish both of these feats. So some problems that I faced were soldering. So originally I had completed everything within the first week. I was pretty much almost done. The next week I was going to finish everything. But then Asher actually gave me a new motor driver, and he's like, here, I want you to use this motor driver instead, because it's a lot smaller. And when I was doing that, I decided that I was going to actually solder all of it together onto one perf board. However, I failed 3 times, and I burned 3 different things. So the first time, I burned my motor driver, the second time I fried my Arduino, and the third time I fried my MPU. So after failing 3 times, eventually my soldering got a lot better, it was a lot faster and a lot cleaner, and on the 4th try I finally got everything working and I put it into my chassis. However, I later found out that my motor and my motor drivers, they weren't sufficient to power the Segway, so I had to break everything again, take out the motor driver, replace it with a new motor driver, unscrew the chassis, unscrew the DC motors, and screw in better ones. So some things that I want to put into next time is a remote control, because right now you can tell that the Segway tries to in this way. If I have a remote control, I'm going to be able to actually pilot the Segway, and after I let go of that, I hope that it can actually just balance itself upright. So some things I've learned were just the quality, patience, and what it means to actually be an engineer. Because I spent about 4 hours the first time soldering everything together, only for one small thing to short circuit and causing nothing to work. And because I had soldered, there's no way for me to take off these parts. The only option I had was just to put it all together again. And I was really frustrated, and Asher told me this story about him, for his final project, he had 12 servers or something on one Arduino, and then he ended up frying the Arduino, and he had to restart it again. So he had to stay up 15 hours or something, the whole night trying to solder everything together. And that just taught me that mistakes are okay, but as long as you learn your failures, everything's going to be alright. Thank you.
How did you determine the parameters for your PID?
So PID, the 3 different values. So P, it's controlling the oscillation, and then D is just trying to reduce that kind of oscillation, and I will be just reducing the amount of overcorrection you have. So you first start with the P, increase it to when you can tap it, there's going to be an oscillation. Then after that, you increase the D so there is no oscillation. And you go back and forth between those 2 until you can find a spot where it's in perfect harmony. And then after that, you can add the I to just decrease the amount of errors that you have.
How easily you can tune your PID?
How easy can I tune it? Oh, it's very easy actually. There's just 3 values in my Arduino, and I just have to change those numbers constantly.
But between those three numbers, you need to find the best set.
Yeah.
Based on the.
Yeah, it takes a lot of time.
Take it out of trial when you have some program to either figure out the best combination.
There is a program, I think it's called like MATLAB or something.
Yeah.
However, to implement MATLAB into this will just make it a lot more complicated.
You have what appears to be a metal bar way up high. Would you be able to explain kind of what that's for?
So this metal bar is actually to increase or like to elevate the center of gravity of the robot so it doesn't have to tilt as much. Originally, it was just this plastic chassis right here, and this caused these motors to have to turn constantly, and it made it like really, really hot after like a minute, and I had to cool them down. But if I like add these wood bars and this metal thing up here, the center of gravity is like higher up, so it can turn a lot more, and it won't turn as much.
Thanks, Leo.